Our second speaker really needs no introduction, but since it's my job, I'm going to introduce him. Thomas Edwards will be presenting a paper on news content distribution using the Time-Addressable Media Store API, or TAMS, which we've already heard quite a bit about during this conference. Thomas Edwards is a principal media and entertainment solutions architect at Amazon Web Services, specializing in broadcast. He previously worked on advanced technology projects for broadcasters PBS, Fox, and Disney. He is a board member of the Video Services Forum, a fellow of SNPTE, and a recipient of the SNPTE Workflow Systems Medal. And I just kind of like to add, Thomas has been very busy at this conference. This is the fourth paper he's presenting, and he's also chaired 2 other sessions. So he's been a very busy guy. Thomas.
Great. Thanks for the introduction, John. Really appreciate it. We're going to talk about I realize this is the last session of the day, so we'll make it snappy. This is about the Time-Addressable Media Store. Now, you may ask, what's the Time-Addressable Media Store? It's a store of media, and every segment of that media is addressed in time. Okay, I'm done now. And I mentioned actually before I go, we should go back. This was actually put together primarily by my fellow solution architects in AWS, John Biltcliffe and Chris Swan, who are based in the UK. But for reasons of frugality, I'll be presenting this presentation. Breaking news. News is what really drives viewers to news channels. And news has a hot value when it's fresh, and that value decreases very rapidly. So the ability to quickly get the news, to quickly clip down and identify the relevant sound bites, which are coming from people who are making news, or the relevant video clips of news events, is super important. And TAMS provides what I think is a really good new technology to be able to handle these kind of quick turnaround editing applications. So we've got broadcasters, and the problem of being a broadcaster is you can't be at all places at all times. And in some places where news is breaking, there's not enough space for all the broadcasters who would like to have their cameras and microphones there. So along came news agencies, folks like Reuters. They can put the cameras in all the places where they need to be, where news might be breaking, and they can then send that news content to the broadcasters, who can then send it out to their viewers. Now, of course, there are lots of broadcasters, and lots of broadcasters will be getting lots of copies of that same news from the news agencies. And actually, there are more than one news agencies out there. So the news agencies are going to be sending multiple copies to the different broadcasters. And of course, the broadcasters will be sending their own news when they are able to film it. They'll be contributing their news back to the news agencies. And even sometimes the broadcasters will send news back and forth to one another with certain agreements. There's a whole news mesh going on. Now, traditionally, a news agency would use geostationary satellites to distribute live feeds of a news event, or they would send it to you via fiber. And by the way, that's a firewall, if you're wondering what that funny thing is. Icons. And the challenge here is the broadcasters have to record these live flows coming out. So they're going to have a certain number of video record systems ready to record the news. Now, while they're recording, they're going to get some stuff that makes no value, right? When there's a rain delay and your camera's pointed out on the pitch, nobody wants to watch the rain. You're waiting for the politician to come up to the podium, no value, but yet you're still recording it on your record systems. EBU color bars, by the way, we're staying international here. What good is color bars or black? It's wasted space on your storage systems. And we have scaling issues too. Most of the time, if you have a fixed amount of recording, usually there won't be enough events to use up all of the recorders you have. So you'll be underutilizing your fixed record capability. When there are more events than your fixed record capability, you're going to miss those events, or you're going to have to figure out some way, well, I'll drop this event, but this is at the White House, so I'll pick this up, but maybe I'll drop the thing that's at the California State House. So sometimes you'll miss events, and most of the time you'll be underutilizing your fixed recording capabilities. So we also have, it'd be a lot of issues regarding how the storage of news media is handled. So, in the past, you'd have content, and you would stick that content, record it onto tape. Weren't those good days? Raise your hand if you've recorded news on tape. Yes. Okay. So still a few. Great. Excellent. Reel to reel. I won't even talk about 2-inch. Anyway, way before my time, personally. That was great. But, the challenge there is being you've got this object that then you'd have to walk around to all the edit systems, to the playout systems, etc. So we've gone way beyond that. So then we started recording high-res files. And the high-res files were really cool, but the problem was they were really huge, and they were a pain to edit. So we invented the proxy file, which is a lot smaller, and you can go through it and figure out what parts you want, and then maybe do an offline edit. We then put those files onto high-performance file systems. And then the cloud came along. So we said, well, we also want to store this media on our object stores in the cloud. And the problem is we're moving the media objects between the high-performance on-premises file systems and the cloud object store. We're duplicating them. Maybe we're kind of losing track of them. We might be needing multiple copies for multiple parts of our organization. We've got live playout, we've got editors, we've got social media people, we've got distribution to streaming. So it all becomes a bit of a mess. Now, of course, your asset management system is going to solve all of these problems for you, right? Maybe. So we asked the question, what if we could change the workflow to suit the cloud rather than simply try to move the solutions that we had on premises to the cloud? And that's where the time-addressable media store came from. So the streaming media people, they're a little bit ahead of us. They've got their content, and they break that content into little segments so that they can send them out segment by segment as HTTP over the internet. And they will have a manifest file that has metadata about the timing of all of those segments. That sounds like a really good idea, because we can break things into segments where they might be more usable, and then we can keep track of their timing with metadata. In adaptive bitrate streaming, you may have multiple resolutions of the video for the available bitrate for your end user. You may also split the components, the audio and the video, up into different segments, but again, keeping track of all of these segments with a metadata file. So we'll move beyond that to the time-addressable media store. Some of you may remember the grains and flows model from BBC R&D, so we'll be coming right into that. So we take these segments of media. Again, some are going to be high-resolution video, some are going to be low-resolution video, some are going to be audio, and we will store those segments as media objects on a cloud object store. And metadata about them, including unique identifiers with UUIDs of each of these media segments, as well as a timestamp, and we'll use TAI, International Atomic Time timestamps, rather than, even though SMPTE timecode is very cool, it repeats itself every 24 hours. So if you were recording over a long period of time, let's say a period of a week, the TAI will keep going up and give you unique indices into the timing of the media segments you're recording. So we'll gather those media segments together into flows. You remember flows and grains? And then we'll gather those into sources of video and audio, and then bring those components into a common content source. And this is a hierarchical model of the time-addressable media store. So you might have, let's say, source A, and you might have source B. Now let's imagine you want to do some cuts-only editing to that, right? Would you want to copy all those segments out into a whole file? No, what we can do is we can kind of pick and choose. We can pick some of the segments from source A and some of the segments from source B and mix them into a new source, which we will call source C. On connected cameras, so you've got a camera which is recording a live event. So it's recording segments on the camera, while at the same time it will also be replicating those segments across some type of wireless connectivity back to the TAM store. Now imagine we lost our wireless connectivity, which has happened sometimes. They get jammed, right? Or they fall over, what have you. We'll still be recording the segments on the camera. And then at a later time, when we have the connectivity back, we can then begin getting the live segments coming in, but we'll also request the segments that we missed until we've got everything we want. There are a bunch of different use cases for time-addressable media store. When you have that live content coming in to the store and being recorded, that content can then be used for live production, for playout. It can go to editing and post-production for news editing. It can be used in social media. It can be used for streaming. Those little segments that we have in the media store can actually be pulled out and turned into HLS segments and then just sent over HTTP as HLS streaming. We can use AI. Every talk we give has to say AI, right? We can use AI to analyze those segments because they're little segments. We can throw them into our multimodal models and get out additional metadata of each of those segments in a very convenient way. And then finally, we can syndicate out to other takers of this content. We can open up our TAM store and allow other takers to browse through our TAM store. They'll be able to see our content, the metadata, giving the timing and other identification of those segments, and they can grab those segments and replicate it over to their TAM store. So at IBC 2025, we had a proof of concept, which we did along with Elliott Media and Reuters. In the London AWS region, Elliott Media, working with UK Parliament, was recording live UK Parliament content onto the TAM store in the London region. And then that content was being live replicated to the Reuters TAM store, which was in the Paris AWS region. In addition, Reuters was also doing some local live ingest, and it was also ingesting files, because you can bring files into the TAM store the same way you can bring in live media. It was doing some frame rate conversion as well with InSync. It had the SOBI as a asset management system, and also had the Omikaze player, which is an open source timeline, so they can actually browse in the TAM segments and see what's actually in the video. And then from Paris, we sent it over to the Dublin AWS region, where AWS had its own TAM store, which was doing live and also replicated transfers from the Reuters TAM store to the AWS TAM store. Again, TAMS is an open source, it's an open source API, and there are different TAMS SDK implementations of them. We have one on AWS, but again, anybody else could be writing a implementation of the TAMS API as well. In the Dublin region, we also had another TAMS tools UI to be able to take a look at what was coming into the TAMS store and to request replication of files, segments which were in the Reuters TAMS store as well. So in terms of transfer, it took about 4 seconds to have live replication from London, from the Parliament material coming to Paris, coming to Dublin, and then I want to say it's about 15 seconds to do a 5-minute clip request replication of material which had already been recorded. Of course, you can probably make that go a little bit faster. You can throw some more Lambda functions at it, or you can have increased data rates. But it's very reasonable replication speed for fast turnaround editing applications. This is a Omikaze player taking a look at a timeline where they're looking into the Reuters TAM store. They're finding some clips. They're bringing them up on the timeline and being able to request the replication of those clips over to our TAM store in Dublin. From a syndication model, it's interesting. You can have a model where maybe people can browse the low res, but you have to have the rights to be able, or purchase the rights to be able to get the high res. So I think it's a very interesting model for those who want to be syndicating news. I think that's one of the reasons why Reuters was excited to be part of this POC. You could imagine all news agencies moving to this kind of model, opening up their stores, allowing broadcasters to come in, look through the news, find that particular clip that's highly relevant, replicate it out at full res, and then take it to air locally. The Digital Production Partnership, or DPP, is working on the Live Production Exchange metadata, or LPX. Right now, this is mainly about future linear broadcasts, or I should say future linear distributions of news. We expect that DPP will begin to look at how we can put TAMs into the LPX so that after an event has happened, the LPX information can carry information about how you can obtain that material, replicating it from a TAM store. So this is the Time-Addressable Media Store.org. It's a web page all about the Time-Addressable Media Store. You can get information about the open source GitHub projects related to TAMs, some additional information and documentation regarding TAMs. I think it's a really exciting new opportunity for the fast replay opportunities, which news broadcasters will be interested in. So thank you.
So we have two questions.
Yeah.
The first, does the open source implementation include code for both server and client?
For both server and client. My belief is that it definitely has for the TAMs, there's code for TAMs store. I think you'll have to probably write your own. The Omikaze player, I believe, has a open source client into the TAM store. But I have to admit, I'm not sure exactly what's available in terms of example code for a client there. But the API is well documented itself. It's BBC R&D is actually the owners of the API definition on GitHub.
So I think that answers the second question, but I'll repeat it anyway. And that is, what is the GitHub repository?
Yes, well, you can go there and find out the information. So.
And then I was wondering, has any experimentation been done using encrypted files?
Not that I'm aware of. There are access management, mechanisms to provide appropriate access management to people. So, you have to, again, have the rights to be able to browse, have the rights to be able to obtain the replicated content. I don't know about encrypted. What do you think would be the use case there?
I guess thinking about, security, very often, news agencies, networks use stringers out in the field.
Mm-hmm.
And they might want to either encrypt the file or watermark the file, to make sure that it's valid.
Yeah. U2PA, the content credential signatures. That'd be interesting. Yeah.
Great. Thomas.
Well, thank you.
Thanks. Great again. Thank you, sir. That concludes our day. I hope you had a profitable day here today. Hope to see you again tomorrow, and hope to see as many of you at tomorrow night's gala to join us to celebrate the awards for our deserving recipients. Thanks, everybody. Have a great night. See you tomorrow.